Hey everyone, welcome to AI Online Course. Today, I'm excited to share a unique project, document augmentation through question generation for enhanced retrieval. In this project, we supercharge traditional document search by generating intelligent questions from PDF content using OpenAI's GPT-4 model. These questions are then used to augment the original document, making it much easier to retrieve the most relevant information during a search. Now, I will present a detailed, step-by-step overview of the entire development process. Step 1. Document input. The process begins with a PDF document. Step 2. Document extraction. We read and collect the text from the PDF file. Step 3. Text splitting. We split the text into chunks to make it easier to work with. Step 4. Question generation. The text is used to create helpful questions on its own. Step 5. Vectorization. The text fragments and questions are embedded. Step 6. Indexing. We use FAISS to create a searchable database of the text. Step 7. Query handling. We search the stored text using the user's query. Step 8. Answer generation. The system gives an answer based on the matching content. Before we start with the code, head over to Google and search for question generation Retrieval Aionlinecourse.com. On AI Online Course, you'll find the complete guide with detailed explanations and well-structured content. Now I'll run the full code step by step in Google Colab, clearly explaining each part so you can easily follow and understand the entire process. First, we mount Google Drive to access and use your Drive files directly in Colab. Now, we install all the necessary libraries to use OpenAI with LangChain. This step also updates LangChain's community tools and installs key packages for language models, PDF processing, vector search, and data handling. We import all the necessary libraries for the project, such as handling text, loading API keys, creating prompts, using OpenAI models, managing documents, and storing searchable text with FAISS. Now, API key configuration. We first try to get the OpenAI API key from Colab secrets. If it's not found, we load it from a.env file. If the key exists, we set it for use. Otherwise, we show an error. Finally, we update the system path and confirm the setup. Then enum and token settings. For question generation, we define how questions will be generated from the document content. An enum is used to set the question generation level, either from the entire document or from smaller fragments. Token limits and overlaps are set for both documents and fragments to control how the text is split. The question generation variable decides whether questions are created at the document or fragment level, and questions PR document sets how many questions will be generated for each part. This setup helps manage the text and ensures effective question generation. Now, pydantic model. An embedding wrapper, we define a pydantic model to store a list of questions generated from a document or fragment, ensuring the data is in the expected format, a list of strings. We also create a wrapper class that extends OpenAI embeddings, allowing the object to be called like a function to generate embeddings for query strings. This makes embedding text easier for similarity search and vector storage. After that, question cleaning utility, the clean and filter questions function takes a list of questions and returns a cleaned version. It removes numbering from the beginning, for example 1 and 2, trims extra spaces, and filters out any items that don't end with a question mark. This ensures the final list contains only properly formatted and relevant questions. Then, question generation function. The generate questions function creates a list of questions from a given text using OpenAI's GPT-4o mini model. It applies a custom prompt to generate a specified number of context-based, answerable questions. After generation, the questions are cleaned, filtered, and deduplicated, ensuring the final list includes only valid questions ending with a question mark. Now, answer generation function. The generate answer function takes some context text and a question, then uses OpenAI's GPT-4o mini model to generate a short, precise answer. It builds a prompt that includes both the context and the question, runs it through the model, and returns the model's response as the final answer. After that, the document splitting function, the split document function, breaks a document into smaller parts. It takes the text, chunk size, and overlap size. It splits the text into words, then creates chunks of the given size, with some overlap between chunks. It returns a list of these smaller text chunks. Then, the document printing utility, the print document function, prints a comment along with details of a document. It shows the comment, the document's type and index from its metadata, and then prints the document's main content. This helps easily identify and review specific document parts. After that, the main pipeline execution now creates text embeddings, generates questions from an example document, and prints them. It then answers the first question, splits the document into chunks, and shows those chunks. Finally, it creates vector embeddings for the document and a sample query, displaying a small part of each. This output shows how the system generates questions from a document, answers one using context, splits the text into chunks, and creates vector embeddings for intelligent search and retrieval using OpenAI and FAISS. Now, the document processing and FAISS retriever creation. This function processes a document by splitting its content into smaller parts, generating questions from either the whole document or its fragments depending on the setting, and creating a combined list of original text and generated questions as documents. It then uses an embedding model to convert these documents into vectors and builds a FAISS vector store for efficient searching. Finally, it returns a retriever that can find the most relevant document chunk based on a search query. Now, the PDF reading function. We read a PDF file, extracts its full text, generates questions from that content, and creates a FAISS vector store for efficient retrieval. It begins by defining a function, using pypdf to read and extract text from each page of the PDF. The path to the PDF file is specified, and the text content is loaded. Then, an OpenAI embeddings model is instantiated to vectorize the documents. The process documents function is called to split the content, generate questions, and build a FAISS retriever. Finally, a sample query is run, and the most relevant document fragment is retrieved and printed. The output shows that your system processed a document by splitting it into smaller fragments, generated questions for each, stored them in a vector database, and successfully retrieved a relevant document in response to a query, "What is climate change?" This confirms that your document processing and retrieval system is working correctly. The query execution and document retrieval. We query the document retriever with a climate-related question and prints the most relevant text fragment from the PDF. The code output shows the question asked and then displays a relevant document fragment retrieved by the system that matches the query. It confirms the system found information related to the effects of climate change on freshwater ecosystems. Finally, the context extraction and answer generation. We extract the original context from the retrieved document's metadata, prints it, generates an answer to the query using that context, and then prints the answer. The output shows a detailed context about how climate change affects ecosystems, followed by a concise answer explaining the impact on freshwater ecosystems, like changes in water flow and biodiversity loss. It also includes technical details about the AI model's usage during the response generation. We successfully built a document augmentation system using question generation to enhance information retrieval with OpenAI models and FAISS. By processing PDF content into chunks, generating relevant questions, and embedding both original and augmented texts, we created a semantic vector store that retrieves the most relevant content and answers queries accurately. This improves the accessibility and understanding of large documents, ideal for building smart Canday systems and research tools. For the full code and to explore more AI projects, visit Aionlinecourse.com, your go-to platform for practical, hands-on learning in AI and machine learning. That's all for today's video. Thank you for watching. If you liked this project, don't forget to hit the like button and subscribe for more tech tutorials.